Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, let's have a go at leaving some values to a particular number of significant figures. So here, I need to leave all of these numbers to two significant figures. The first one, 11.12, well, my first significant figure is that first one, and then my second significant figure is that next one. So now I just need to check whether I need to round that final significant figure up or if I can just leave it as the 1. So you'll see after the decimal point here, the next number is a 1. So that's fine. I don't need to round my answer up, and I can have 11 there as my two significant figures. Okay, next here is 0.985. Now, it's important to note that zeros do not count as significant figures unless there are numbers that come before the 0. So here, that 0 is not significant. So my first significant figure is that 9. And then my second significant figure is that 8. But again, I just need to check if I need to round that 8 up or not. So I have a look at the next figure along, that's that 5. And since it's a 5 after, if it's 5 or higher, I need to round up. So I'll have to leave my answer as 0.99 to two significant figures. Okay, next one here. None of those zeros count as significant figures because they don't have numbers before them. So my first significant figure is the 8. The second one is the 7. Do I need to round that 7 up? No, because the number that comes after it is a 4. So I've got 0.0087. Okay, now here my first significant figure is the 1. And my second significant figure this time is that 0 because it had numbers before it. So am I going to leave my answer as 100? Well, no, because the number that comes after that 0 is a 5. So I have to round up, and that gives me 110 to two significant figures. Okay, and finally here I've got 0.8023. So that first 0 is not significant because there's nothing before it. My first significant figure here is the 8. And my second significant figure is that next 0 because it has the 8 that comes before it. Do I need to round that 0 up? No, because the next number is 2. So I'll leave my answer as 0.80. Okay, time to move on to some prefix conversions. So you need to have that table of prefixes open in front of you to complete these answers. Remember, you do need to learn that table eventually. So first one here, I'm dealing with converting from something that has a prefix, so 6 milliamps, to something without a prefix, so just into amps. And how I'm going to do that is I'm going to take my 6, and all I have to do is multiply by the number that is in the table. So for milli, my number is 10 to the minus 3. So 6 times 10 to the minus 3 gives me 0.006 amps. Okay, and next on my list is to convert 70 megawatts into watts. Okay, so from prefix to no prefix. Again, just look at my table, find mega, that's 10 to the 6, and multiply my number by that. So I've got 70 times 10 to the 6, and that is 70 million watts. Okay, and finally here, 90,000 nanocoulombs into coulombs. Again, look at my number in the table, it's 10 to the minus 9, and just simply multiply my figure by 10 to the minus 9, 0.00009 coulombs.
Okay, and then you might get asked to do this the other way round. So this time we're going to go from 30,000 amps, so something without a prefix, to something with a prefix. And the only difference here is instead of multiplying by your number, you have to divide by your number. So 30,000, I look at kilo in my table, and that is 10 to the power of 3. And so I need to divide by 10 to the power of 3. And that gives me 30 kiloamps. Okay, and following the same idea, 49 watts to centiwatts. Okay, I look at my table, centi is 10 to the minus 2. So 49 divided by 10 to the minus 2. I get 4,900 centiwatts. And then here, convert 7,200,000 coulombs to gigacoulombs. Giga is 10 to the 9. If I divide that by 10 to the 9, I get the following answer. Okay, time to do some time conversions. So convert 5 hours into minutes. So again, check out my notes and we can see how to convert between all of these different units of time. I'm going from hours into minutes, so I have a look and see that I need to multiply my answer by 60. So that gives me 300 minutes. Next one, convert 5 minutes into seconds. To go from minutes to seconds, again, I multiply my number by 60, 300 seconds. Next one, convert 6.2 hours to seconds. So first, I need to convert it from hours to minutes. That's multiplying by 60. Then minutes to seconds, need to multiply by 60 again. So 6.2 times 60 times 60 gives me 22,320 seconds. Okay, now how to go kind of the other way round, so converting 7,000 seconds to hours. This time, instead of multiplying by 60 and 60, I need to do the reverse. So divide by 60 to get to minutes, and divide by 60 again to get to hours, and that gives me 1.94 hours. Convert 93 minutes to hours. Well, to go from minutes into hours, I just need to divide by 60 once, and that gives me 1.55 hours. How many seconds are there in a weekend? So, slightly trickier question now. I first need to think about how many days are in a weekend. 2 days in a weekend. Why? Because I'm trying to work out how many hours there are in a weekend first. So there are 2 days and there are 24 hours in each day. So 2 times 24, that's my number of hours. Then to get to minutes, times 60, and to seconds, times 60 again. 172,800 seconds in a weekend.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, tips and tricks for this section. So the first tip is time in your equations is usually in seconds, okay? So if they give you a time in minutes, you will need to convert it into seconds before you can plug that time into your equations. Second trick is there are always marks to be gained somewhere throughout your papers for leaving your answer to a certain number of significant figures. So you need to look for where it says, please leave your answer to 2 significant figures, and make sure you've done it, because it's marks that some pupils lose. Okay, and finally, your calculator function. If you have a look at your calculator here, along the bottom line is that times 10 to the x function there. And I like to use that for some of my conversions. So if I'd like to convert, let's say 3 milliamps into amps, I type 3, then I press that button, and then I put minus 3, and that does it straight for me there. Okay, that plugs all that information into my calculator. The reason I think this is quite good is because if instead you kind of did 0.00 3, you're likely to put in the wrong number of zeros into your answer. So that can be helpful as well.